Okay, this is R.6, Review 6, Radical Notation and Rational Exponents on page number 38. We're going to do a lot of skipping around here since most of this is so much review, but it has to do with radicals. So probably the first thing I want to do is talk to you about what happens when we have the square or the cubed root of 125. Okay, so what we've got here is the radical, which is right here. This is the radical. This is called the index, and this is called the radicand. The 125 is called the radicand. So just some vocabulary there to remember. And one of the things that you need to realize when you're dealing with square root of something like square root of 36, okay, that's going to be 6. It's also going to be negative 6 because both 6 and negative 6 squared are going to give you 36. But when you get the positive square root of a number, it's called the principal root, and that's usually the one that we're going to use. And for the most part, that's what we're dealing with, is that principal root. So if you look at example 1, a couple things I want to look at is negative square root of 36 means we take the square root of 36 and stick the negative on it. The cubed root of negative 8 is going to be negative 2 because negative 2 times negative 2 times negative 2 is negative 8. The only time we can have a negative in here and have it actually work is when our index is an odd number, and then it works. Whenever our index is an even number, we can't have a negative sign under the square root. And also, this is example 1D. When we have the fifth root as our index, and we have 32 over 243, that is the same as the fifth root of 32 over the fifth root of 243. And in this case, that would be 2 over 3, because 2 times 2 times 2, 5 times, 3 times 3 times 5 times is 243. So that's where we get that. If we have the fourth root of a negative number like that, that cannot be done because there's a negative there and this is even. One of them, either this has to be odd or this has to go away. You can't have both of them up here. Which takes us to page number 40, Simplifying Radical Equations. So when we do that, it helps to look in that blue box, Properties of Radicals, on page 40. And that really helps you to have an idea of what we're looking for. So let's jump down to example 2 and look at A when we have a radical like this. Okay, one of the things that's important is knowing that negative 5 times negative 5 is 25, and the square root of that is 5. So what we come up with is that if the exponent is the same as the index, we can just get rid of the radical sign and the exponent right here and get the square root, or the absolute value of whatever's under the radical sign. So in this case 5, square the absolute value of negative 5. If we have a cubed root of a negative 5 like that is cubed, these are the same and they're both odd. So then we don't need to worry about taking the absolute value, and we just get negative 5 for an answer. So again, when these are odd numbers, if they're the same, you just take all the signs away and you get this. If they're even like this, whether they're 2, 4, 6, or 8 or whatever, it's the absolute value of what's under here because it has to be positive. Okay. C has the fourth root. Oops, let me get the pen here. The fourth root of 4 times the fourth root of 5. Okay, so when that occurs, when the index is the same, we can just multiply the radicands together, like that. And with that can't be reduced because it's a fourth root, so we're done there. As we continue on here, let's see if I can get rid of this. Alright, so if we have square root of 50, what I always tell students is, if we're going to reduce that, if we're going to simplify that, what we're going to look for is the factors of the radicand, and hopefully we're going to try to find at least one of the factors that I can take the square root of. Alright, so really the factors here are the square root of 10, square root of 5. I can't take the square root of either one of those, so I don't want that one. But square root of 25 times the square root of 2, I can take the square root of that, so I want that. Square root of 25 is 5. Square root of 2 is left over. That ends up being the simplification of the square root of 50. So if I find two factors where one of them you can take the square root of, and ideally the other one is a prime number, and then you're reduced as much as you can go. Alright, so when we have something like the square root of 72 over square root of 6, and again I'm still in example 2 and this is part E. This is actually equal to the square root of 72 over 6, which is the square root of 12. And the square root of 12, that breaks down to the square root of 4, square root of 3. I picked that over 6 times 2 because I can take the square root of that and get 2, and I've got square root of 3, and that ends up being the simplification. Okay, now if you look at F there, F is where we're starting to get into some of the fun stuff. We have the cubed root of 8 to the 5th power. Okay, I don't know about you, but to simplify this, well, let's just do it the way the book does. They get the cubed root of 8, and then that is to the 5th power. So notice you can take this and pull that out. So the cubed root of 8 is 2, and then we take that to the 5th power, and that's a lot easier to do than to take 8 to the 5th power and then take the cubed root of it. So that's just showing you can do the cubed root first and then do the exponent, and that will make life so much easier. Okay, G is 2, 1, 6, x to the 5th, y to the 5th, and they're going to take the square root of that. What they did is they broke that down again into 36, which I can take the square root of, which is nice, times 6 for the 216. And then we've got our x to the 5th, y to the 5th. Alright, so now that we've done that, we'll start pulling things out. Square root of 36 is 6. And that leaves our 6 in there, this one right here. X to the 5th. Okay, so we take, this is a 2, so we take 2, this 2 right here. How many times does 2 go into 5? 2 times. So that means I can pull out 2 x's, which means I have 1 left. Okay, so 2 goes into 5. Let me get my pointer. 2 goes into 5 2 times with 1 left over. 2 goes into 5 2 times with 1 left over. And you're done. That's the easiest way to simplify that. Okay. Next one is hx squared over 16, and they're taking the square root of that. We can write that as the square root of x squared over the square root of 16. And we'll take the principal root here of square root of 16 is 4. And what we're going to do here is remember, if the index and the exponent are the same, it has to be the absolute value if it's even. If it's odd, it doesn't have to be. Okay. And actually, if we were to do this correctly, g above, we would have to make that this absolute value too, since we took this is actually 6 squared, and we took that's even, and this would end up being absolute value, but I don't get too caught up with all of that. Alright, so let's call that the end of R.6a. Okay, 10 minutes 39 seconds, and then we will continue on with example 3 up through the rest of this lesson in R.6, B as in boy.